Hello, we are MEM Team number 2. Our project was sponsored by Dymax Corporation and was the output improvement of screw assembly process. In addition to our sponsors, we also worked alongside our mechanical engineering counterparts. Our sponsor Dymax is a global leader in the manufacturing of light curable adhesives, coatings, UV and LED light curing systems, as well as fluid dispensing systems. They are headquartered in Torrington, Connecticut. Our group was tasked with improving the over-torque and under-torque failures that Dymax was having in their manufacturing processes that were leading to first-pass assembly internal failures. Our deliverables include a reduction of the first-pass assembly internal failures from 7% to 1%, a cost-benefit analysis of our proposed solution, and work instructions for the implementation of our solution into their processes. Our project began with the analysis of the current manufacturing process, followed by extensive research of the industry's best practices. Through this research, we determined that an automated screwdriver was the best solution to lowering the amount of torque issues in Dymax's manufacturing processes. We created this comparative table of the top 3 choices we found through the research. With this information, Dymax decided to move forward with the Culver KDS PL15 transducerized screwdriver and begin testing. Our team was given 2 systems to test the Culver device on, one being an ECE power supply and the other an ECE flood lamp. Prior to actually testing the device, we created a testing protocol to ensure that the implementation of this device in Dymax's manufacturing process will consistently produce parts that meet requirements. Once the protocol was approved, testing began. Through further research and data given to us from our sponsors, we were able to set torque specifications which we thought the actual torque values should be similar to for each screw. The Culver device allowed us to find experimentally determined torque values for all the screws, as well as the time it took to tighten each screw. These 2 images were taken from our testing. They are a good visual representation of both the ease of use and the time saved from the Culver device.
Our recommendations prior to the implementation of the tooling proposal was to perform an ergonomic assessment before, during, and after said implementation to ensure safety and mitigate any issues that may come up in the process. We developed work instructions for the use and setup of new tooling in order to ensure a smooth transition for the operators. Finally, from both our learnings from the ergonomic assessment and some lean concepts, the most fitting layout proposal was created. From the time studies conducted, we obtained an average cycle time of 43 minutes with the manual hand tool and 30 minutes with the proposed screwdriver. So approximately a 13-minute difference in cycle time, where we also consider a 15% efficiency factor in order to take into account fatigue and any other delays within the process. Additionally, we also factored in an 8-hour shift and the breaks such as lunchtime in order to calculate pieces per hour and per shift. The transducerized screwdriver shows favorable results since it is able to produce 1.5 times the output of the manual hand tool. The run hours are based on how long it takes to produce 10 pieces, and with that number and the new first pass yield of 99%, we were able to obtain labor savings per unit of approximately $7. This is considering assumed labor rates close to industry average but not the actual labor rates. From this calculation, we determined that by implementing our tooling proposal, we will be able to decrease labor hours and direct labor per unit by 31.5%.
The first pass yield is portrayed on the graphs on top. The graph left shows a 7% failure rate for the screw issues in the year 2020. The graph right is this year's projected FPY change, which considers screw tension issues mitigated by the implementation of the Culver screwdriver and compares them to the current average from the left graph to the expected values in green and in blue. The tool issues will eliminate 90% of screw issues. The device displays screw number into programs and identify lost/missing screws by counting. Tool slows down when the value is reached, preventing over and under screwing. The 1% error on the projected graph takes into account any error. The bottom chart has experimental torque values and cycle time of the tightening screw assembly at the specified torque value and 125 RPM speed. The Culver device improves ergonomic and process FMEA numbers. For ergonomics, the screwdriver keeps the wrist and elbow neutral and the shoulder in a more relaxed position, addressing manual tooling problems of rotated forearm and shrugged shoulders. The wrist is a concern as force exerted in a repetitive task can result in cumulative trauma disorder. The ergonomic soft touch design and torque arms can help prevent wrist twists. For PMEA, the left score is manual tool score, S is severity, O is occurrence, D detection, and a higher score is not preferred. These values take into account 15 tasks, 14 under and over torque related failures. Detection scores decrease as torque can be preset. Occurrence has potential to decrease with improved ergonomics, and severity scores the same throughout the PMEA. Thank you for watching.